Greetings and welcome to my new YouTube channel, Palezoic PCs, where prehistoric computers walk the earth. So this month of September is apparently Septandy, as declared by several other tech YouTubers. And so even though it's still just barely September, I figured this was the golden opportunity for me to go ahead and share with the world some projects I've been working on for my Tandy 1000EX personal computer here. If you're watching this video, you probably know what a Tandy 1000 is, so I'm going to save you the whole history of the machine. There are plenty of good videos out there by other YouTubers. So let me just talk briefly about this machine. So I bought this machine a few months ago, and as you see, it's very tricked out right now. But when I bought it, it was just the machine. Just the bare box. No external drives, no joysticks, no peripherals, and most importantly, no memory card. It was just the bare 256K machine. It did not have the plus memory adapter, which is necessary for these machines to go above 256K. And actually even to add more than one expansion board to them. So the one slot on the motherboard was filled with this humble little 1200 baud modem, which isn't a whole lot of use these days. So when I started working on the machine, the first thing I did was I went ahead and I replaced the original floppy drive with a Gotek drive hacked with the open source flash floppy firmware, which allows these Goteks, which are very inflexible out of the box, to emulate almost any Shugart interface floppy drive for almost any system. Another modification I made to it was I did the mod where you can replace the 7-segment numeric display on the Gotek with a little OLED alphanumeric display. And this is a mod I highly recommend. It really improves the usability of the device. I had a couple of these old craft joysticks lying around, and they were PC compatible. So I went ahead and I swapped the original D connector for the proprietary 8-pin connector that Tandy used. So after I did that, I started playing with the machine, and probably other owners of these machines can sympathize with this. You will probably realize pretty quickly that 256K is very limiting on these machines. So, as you probably know, these machines were based in part on IBM's PC Junior. That's what gives them their enhanced graphics and sounds. But they're not completely IBM PC Junior compatible. So even though there's a fair body of software out there that will run on the original 128K PC Junior, a lot of it has little problems on the Tandy 1000. It's not a slam dunk it's going to run. So, on the other hand, there's a fair body of software out there, and it's the reason for getting one of these, that also is specifically programmed to run on the Tandy 1000 series. Unfortunately, you'll find that a lot of that software requires more than 256K of memory. So there's really not a whole lot you can do with this machine like this. I mean, really, to be honest, these were introduced around 1986. And this machine was sold for a couple years, and then it was replaced by another machine, the Tandy 1000HX, which had two 3.5-inch drives instead of the single 5 1/4 on the side, but is otherwise pretty much identical. They actually sold that up through 1990. And 256K was probably a marginal proposition even back in 1986, but as it turns out, it seems like there are significantly more of these machines in the wild than you would expect that do not have the memory expansion. So I, of course, did the research and checked on eBay, and it's pretty simple. If you want to get the original memory card for these machines, the only way to really get it is to buy another machine that already has it installed. So, other problems with the base configuration, with only a single floppy drive, swapping disk images gets pretty old. And another issue is these only have the joystick ports and a printer port for external connectivity, so there is no standard port on them for connecting, say, a mouse, and there's no serial port for connecting them up to other computers with whatever. So as you can imagine, I was kind of stuck. Now to be fair, there are some solutions out there that involve adapters for the proprietary connector on the motherboard to turn that into a couple of standard ISA slots, and you can kind of loosely pile a couple ISA cards inside of it, and that will work perfectly well for simple purposes. But I've been collecting old computers for a few years, very casually, and for a long time I have had the yen to actually try to start doing real projects with them, making expansions for them. So I decided that once and for all, I was going to use this poor little Tandy 1000 as my guinea pig. So I have completely from scratch built all the expansions necessary to expand this machine to what you see here, which is 640K plus. Talk a little bit more about that. Mouse port, a second serial port for communicating with other machines, and it has an IDE, an XT IDE based mass storage controller inside, all without using any adapters. So since I thought this might be of interest to some people that have these machines and are looking to expand them, that's what I've made this video here for. So first thing, let me go ahead and reposition the camera a little bit, and I will give you a quick rundown of what you can do with your expanded Tandy 1000 EX, and then I will quickly give you a quick rundown of the actual boards that I have built and installed. So, one moment. So, let me go ahead and fire this machine up and see what lives inside. So, as you can see, this machine recognizes 640K. That's the built-in 256K plus 384K of additional memory, just like you would get with the original Tandy board. So, this right here is the XT IDE Universal BIOS. You can see it recognizes a flash drive. Now, this is where it gets special. This spew right here is the output from useumb.sys and dosmax.exe. And these two drivers are used on machines like XTs and 286s that have upper memory available to load DOS and device drivers high. So the special thing about the memory card in this thing is it has a 512K static RAM chip on it. And in addition to using 384K of it to fill in lower memory, the remaining 128K, through a little trick I came up with, is mapped so it can reside in the D and E areas of the upper memory space. So on an EX here, that means you can get up to 128K of upper memory. And as you can see, DOS itself, because part of it is loaded high, has 610K available in lower memory space, which this is approximately a 40K improvement over what it would have on a Tandy 1000 like this, running without upper memory blocks. So you can see the rest of this. This is where it says system here. That is the memory occupied by DOS plus all the unusable parts of upper memory. So you can see, as you saw on top, DOS was only occupying like 10K of lower memory. This is the DOS Max driver, files, buffers, and you can see that the mouse driver also can load it to upper memory. So, as you see, almost 610K available, and we still have 80K upper memory space. So let me show you quickly. Check It is a well-regarded diagnostics program for older PCs. And so let's see briefly see what it thinks of my computer here. So as you can see, we are running DOS 5. This is an upgrade I didn't mention earlier. I've also replaced the 8088 chip in this machine with a V20. It gives a small speed upgrade. It's nothing to write home about, but every little bit helps. You can see base memory is 624K. Now again, if you're familiar with Tandy 1000s, you know that at least on all the 8088 and 8086 models, the video memory is always shared with the CPU as part of base memory, and that means that part of main memory is always borrowed for use by the video controller, and the minimum amount it will borrow is 16K because that's what CGA has. So a Tandy 1000 like this can never have 640K. It has 624K, and that's fine. It's a Tandy 1000. So you see, I have a 256 megabyte hard drive, which is actually a CompactFlash card, and I have 2 serial ports. I have a mouse. So if I look at the memory map, give it a moment while it spelunks around upper memory here. Take your time. Go on. I have just under 640K of lower memory. If this was a regular PC, this would stop at 9FFF, not 9BFF. Then we have here, there is a 64K flash ROM chip in this thing, and it is mapped into the C page. Now, for some future version of this board, I think I would actually reduce the 64K allocation to 32K or possibly even smaller, so it would leave some address space for use with something like a network card or possibly a VGA card, because I know there are people that have actually stuck those on these. But for now, it occupies a full 64K. This says a video ROM. The reason it says that is check it. EGA and VGA cards generally put their BIOSes there. So it assumes if it sees a BIOS there, it's a video ROM. But if we actually look at the dump of the ROM, you can see it's the ID Universal BIOS. So then we have here 47K occupied in upper memory. If we look at this, we see the DOS Max environment. This 36K right here is the part of DOS itself that was actually loaded high. Then you see files, buffers, flash drive, and CT mouse. And we still have 81K available for more programs, which is fantastic. That is almost enough to hold a decent DOS TCP stack. So again, I'm kind of itching to see if maybe I can put a real network card in one of these as well. But so that's that. If we look at the benchmarks, let's do the hard disk first. So as you can see, 293K per second, which is much faster than the original IBM XT hard drive. Now, admittedly, the IBM XT had a particularly slow hard drive. A better controller could usually do closer to 150, 160K. But 300K per second is still pretty good. And you see the seek times are far faster on a CF card. So no problem substituting for a hard disk here. And the main system. As you see, it's about 1.5 times as fast as an IBM XT, which is great for a Tandy 1000EX. So let's have my hands on this. Now, the next program I'm going to go ahead and fire up for you is the old school PC benchmark top bench. So, the reason we're firing up top bench is this to address one, I'm going to say quote-unquote deficiency of this card, and actually basically any currently manufactured alternative for adding memory to these machines compared to the original Radio Shack card, which is this card does not have a DMA controller chip. Now, obviously there are some downsides to that. There are some interface cards that require DMA, although there are actually very few ISA cards that you would really want to actually use in EX or HX that actually need it. I mean, the short list would probably be maybe a Sound Blaster card, but it has Tandy graphics and sound. What do you want a Sound Blaster card for? Also, if you were to use an original old school IBM XT compatible hard drive in it, most of those controllers required DMA. And the also oft-repeated saw about DMA is that having it makes floppy I/O faster. Now, technically speaking, it's probably more accurate to say that having it can make floppy I/O a little bit more efficient. But it's actually only some pretty rare edge cases where it actually makes a significant difference. That said, are there advantages to not having a DMA controller? And that's what I'm going to show you. So I'm going to go ahead and hit the real-time benchmarking on this machine. And there it is. And you see the score is very stable on this. If I move the mouse around, I can make it vary a little bit. But as you see, this score is a tie for this recorded score here, which is a Tandy 1000EX with a V20 and SRAM. So let's keep that in mind. And you see it's about as fast as these are basically 8 megahertz 8088s. So let's go ahead and exit this. And we will look at the compare system screen. Now, give me a second to get this set up. I'm going to put this machine's score on the top, and then we will compare it to some other Tandy 1000s on the bottom. All right. So this is the machine's score, and this is the score from an original Tandy 1000EX that has the Radio Shack board in it. Now, as you can see, this one's way faster. This one is 33% faster. Now, unfortunately, these scores are not directly comparable because this one has the original 8088. This has the V20, and particularly having a V20 because of some deficiencies in the 8088 can make things like memory access ridiculously faster. So that one doesn't really count. But luckily, the score for an HX in this database, and again, the HX is essentially the same machine. It has the same CPU speed, almost the same motherboard. This one also has a V20, and it also has the Radio Shack card with the DMA controller chip. And as you can see, this machine is approximately 14% faster than that other machine. Now the question would be, why? And the answer is that the main function of a DMA chip in an original IBM PC and on an original Tandy 1000 that has the original card is not to deal with peripherals, it's actually to refresh main memory. Now, I actually recorded a really long spiel about this. I'm not going to, nobody wants to listen to that. So the short version is that dynamic memory needs to be read on a very regular basis, every few fractions of a second, in order to refresh it. And if that doesn't happen, it will forget whatever is stored in it. So the way that's handled without having to use a software loop on the original IBM PC is it uses the DMA controller chip attached to the timer chip. So that every 15 microseconds, a signal is set to the DMA chip, which causes it to run through a section of memory and basically trigger the row address lines on the chips, and it just dumps that, it dumps the read to dev null. But it is doing that basically 66,000 times a second. And if you go ahead and look that up in your favorite reference, that you'll find that that actually adds up to about a 10 to 15% overhead for the total memory performance of the machine. And that is confirmed by TopBench here. So, pros and cons. Not having the DMA controller does sacrifice some compatibility with ISA cards that you're probably not going to use in this machine anyway. And it means the floppy controller isn't as good as you might like. But on the pro side, it means that whenever the CPU wants to access RAM, it can access RAM, and therefore the machine will actually perform slightly faster. As you can see, if you consider the difference between these two machines, having this memory card makes it almost as much faster as the V20 upgrade does. And again, the thing to keep in mind is that most common ISA cards do not need DMA. Serial ports don't need DMA. You can use an ad-lib card or a MIDI card. Most network cards don't use it. And of course, the XT IDE controller that this is equipped with doesn't even need an interrupt, let alone DMA. That's the case because the timing requirements of modern IDE are actually much more forgiving than that of old real spinning disk controllers. So there you go. That is, again, that's the objection that's often made for using anything but the original card is no DMA. But I've decided to not let it bother me. So let me go ahead and exit this, and let me just quickly walk through some of the other things that you can do with this machine now that you can't do with an original unmodified 256K EX or HX. So this is a PC paintbrush, one of the later 3X versions. I used to love the heck out of this program when I was a kid. So as you see, it runs with mouse support. It's got the full 16 color Tandy palette in this mode. It has more than adequate RAM available to do what it needs to do. So let's go on to something else. So a really good use for the second serial port on the serial card is downloading files over Kermit. It's not super fast, but beats having to make a floppy disk image. And we find out that RoboCop is indeed the future of law enforcement. Okay, so the last thing I'm going to go ahead and do here is I'm going to start a PPT daemon over here on my little laptop, and I'm going to show you how you can get online in a kind of limited way with a Tandy 1000 and a serial port. So first thing I'm going to do, I'm going to type load hi EPPDD 2 115200 local. Voila, we have a packet driver installed. So let me do a quick mem/c here and show you. ePPD. This is a PPD daemon that emulates having an Ethernet card. There's DOS internet is confusing, but the long and short of it is that you get somewhat better compatibility with software if you emulate an Ethernet card than if you try to be a PPD dialer. So that's what this does. As you can see, this simple driver takes up 66K of memory. So, but it's all loaded high on this. We still have 610K of low memory. So with that installed, we can ping google.com. And that's pretty much all we can do, really. I mean, I'll be honest. The ePPD does not perform well on a system this slow, and I find that the HTTP and FTP daemons have had some issues. I've gotten them to work by doing some packet shaping on the upstream side, but it's pretty hard for them to keep up. But one thing that does work pretty well is the Telnet software. So you can go to There's many old BBSs that have been reborn as Telnet BBSs, and you can actually visit them with your Tandy 1000. So as a final thing here, why don't I just go ahead and give you an actual look at what is hiding inside the box here. So, as you see, we've got a stack of expansion cards in here. This is a serial card. The next one down is the IDE adapter, and at the bottom, pretty much where you can't see it, is the memory card. So let's start from the bottom up. This is the card that replaces the missing memory card. So as mentioned, this has a 512K RAM chip that lives in this socket here. The flash chip lives in this socket here, and that clock calendar chip lives here. You see there's a supporting battery, crystal, and this is all the decoding. As you see, it's a pretty minimal card. You only need 3 decoding chips and a buffer chip to support these 3 things. It has the standard layout as you would have on a Plus card, where you've got the middle bus connector here is the one that takes a female connector that connects to the header that's sticking up out of the motherboard. And then these 2 bus slots are filled with male headers of different heights. So, this whole thing makes a sandwich. The middle card is offset this way, and the upper card is offset a little this way compared to the slot on the motherboard. So, next slot up is the very simple IDE card. As you see, it only has 3 chips on it. It can be that simple because we put the ROM chip on this card. The reason I did that is because the decoding that was necessary to enable the upper memory blocks was essentially the same decoding I needed for the ROM chip. So, killed several birds with one stone. So this is a very simple card. It is compatible with the XT-CF-Lite revision 2. which means it's only an 8-bit subset of IDE, which means it doesn't work with most hard drives, but it works great with CompactFlash cards in these little passive adapters. So the final card we've got here is the serial card. Here's the bare board, just like we got, but it's right here. As you see, this is a dual serial card, but only uses a single UART chip. It uses the 16552 dual UART. It uses, these are the standard bipolar transceiver chips, and there's the decoding down there. And in case you're wondering, as you see, these are quite small cards compared to the original modem card. And of course, the original plus memory card was quite a lot bigger than even this modem card. The reason for that is simply the inexpensive PCB houses, like the one I use, PCBWay, they offer very inexpensive prototype rates for boards under 100 by 100 millimeters. So I decided I was going to prove out all the circuits on these small boards, and possibly if these were ever to go into production, maybe we could think about getting bigger boards and combining some of the functions onto single boards, which would be useful. And ideally, I'd like my goal to be getting either the serial in the IDE or the memory in the IDE on the same board, so I could save the third slot for possibly a network card. So I think that's it for this video. In a future video, I think I might like to talk a little more about the nitty-gritty of how these cards work. And I'd also like to talk about possibly, I mentioned there were alternatives that you can buy today. If you're really desperate to one of these machines, I think some of what I've learned in building these cards could be useful in building, in cobbling together your own expansion out of those adapters. Particularly, there are quirks about the way the memory mapping is done in these machines that affects, if you want to use, say, like the low-tech 1 meg XT memory expansion card, you have to configure it differently than you would in an XT with 256K to make that work. So if you are interested in having one of these cards, like I said, these are prototypes, these are not in production yet. Honestly, one of my reasons for making this video is to try to figure out if there's actually enough demand for these things to think about making refined versions of them that were good to sell. The EX here is actually the rare of these machines. The HX seems to be much more popular. So another thing I would like to do is verify that these cards work in an HX. To that end, a kind member of the Vintage Computer Forums, goes by the name Retro Gaming Roundup, has actually donated this, which is a HX motherboard. And I'm hoping soon I will have the time to actually maybe get this and set it up with the cards inside my machine and see if it will fire up with them inside as it is. Or if it doesn't work, I can maybe use this board to suss out what the problems are. So again, I'd like to thank Retro Gaming Roundup. I will put a link to his page and podcast in the description. And I thank you for watching my first YouTube video, and have a good day. Thank you.